Hello everyone, this is Rajiv Ranjan Kumar, intern at Emertxe Information and Technology. Today I am here to share about my learnings of this internship. So let's begin with the abstract. I have successfully completed my embedded system internship from Emerging Information and Technology. Here I used PixSim Lab for testing and MP Lab IDE for programming, and by using both I have learned how microwave work. Learning of this internship. I learned here about advanced C, about microprocessor and microcontroller project implementation. In advanced C, I learned about introduction to data types, printf, scanf, block, switch case, while do loop, and ternary operator, overflow, underflow, array pointer, string, storage classes, preprocessor, macros. So in second microprocessor and microcontroller, I learned about what is microprocessor, microcontroller, what is embedded system, and what is level tracking, age stream, interrupts of microcontrollers, microprocessor timers, and many things in that. And the last is project implementation, in which I simulated the Pixim lab. In that I learned about microwave oven, how oven works, and I have done the programming of microwave oven. So let's see the next slide. The contents. Today I am going to explain these all contents: introduction, block diagram, working, software material used, embedded programming, application, advantage and disadvantage, conclusion. And also I will be explaining about the simulation of the microwave oven. That was the project. Introduction. A microwave oven is a kitchen appliance, an electric oven that heats and cooks food by exposing of electromagnetic radiation in the microwave frequency range. It is an embedded system interface with the external environment by means of several sensors and actuators. What is embedded system? Now see, let's about the embedded system. So let's begin about embedded system. So embedded system is a combination of hardware and software, and embedded system is a specialized computing system designed to perform a dedicated function within a larger system. Unlike general purpose computer like PCs, embedded systems are optimized for a specific task, often with real-time constraint. They integrate hardware and software to control device, process data, and interact with physical world. So let's see more about the embedded system. Yes, embedded system is a standalone system, work independently without host computer. Example: digital camera, MP3 player, microwave oven. Real-time embedded system process data within a strict time limit. Soft real-time, small delays are acceptable. And second is hard real-time, no delays allowed. Network embedded system connected via network, Wi-Fi, or communicate with other systems. Example: smart home devices, industrial automation system. And fourth is mobile embedded system used in portable devices like a smartphone, GPS, and smartwatches. So let's see components of embedded system. Embedded system is a combination of microcontroller and memory, input output interface, communication interface, power supply. That's all about embedded system. Now let's see next slide, which is the block diagram of microwave. So in microwave there is a combination of power circuit, magnetron, temperature sensor, humidity sensor, LED panel, and PORIC, IGBT coupler, and LED keypad matrix. And this I will show in the board of the PixSim lab, which I have used in simulation. A working magnetron takes electricity from power outlet and converts it into high power during cooking. The magnetron blasts these waves into the food compartment through a channel. Software used during this internship is MP Lab IDE, PixLab, PIC Genesis. Architecture of PixSim Lab. So I am showing explaining about the architecture of the PixSim Lab one by one. So here we can see GPIO, means GPIO pin. GPIO pin is used to this programmable digital pin that can function as either input or output. It is used to control read external devices like LED, switches, and sensors. And second is I2C RTC EEPROM. I2C is inter-integrated circuit and RTC EEPROM. I2C is communication protocol used for connecting multiple peripheral devices. RTC stands for real-time clock, keeps track of time and date even when the system is powered off. Double EEPROM is electrically erasable, programmable, read-only memory used for non-volatile storage, meaning data is retained even after power loss. Now see LM35 temperature sensor. The LM35 is an analog temperature sensor that provides a linear voltage output corresponding to temperature in Celsius. The PIC microcontroller reads this voltage using ADC, analog to digital converter, to determine temperature. Now let's see about the RS232 serial communication. RS232 is a standard communication protocol used for serial data transfer. It allows microcontroller to communicate with external devices like computer, GSM modules, and other microcontrollers. And LEDs. LED stands for light emitting diode, used to indicator for various operations such as power status, warning, debugging. Next is buzzer. Buzzer is used to audio alerts or alarm. It can provide feedback for user actions or indicate fault condition. Digital keypad, a numeric functional keypad used for user input, typically used for entering password, commands, or numerical data. And next is SSDs. SSDs stand for 7-segment display, used to display numerical information such as sensor reading, time, or user input. Next is matrix keyboard, a larger input device with multiple keys arranged in rows and columns, used for user interaction like applications like security system, calculators, or menu-based navigation. Here in the micro operation, we will be entering the times and everything using the matrix keyboard. Now let's see next. Next is the Pixim Lab board, which I have used in the project and simulation of this during the internship. So here we can see the 7-segment displays, 16x2 display, heater, cooler, buzzer, everything is embedded in the system. So we have used this board for our simulations, and I will be showing the simulation video after the PPD. This is embedded C programming, which we have learned during the internship. Here the 4 modules which I have used during the internship is modules.c implementation file. This file contains function implementation. It includes the supporting header file, supporting underscore file.h, defines a function1 which contains core functionality, and functions from this file are called in the main program as needed. Second is main.c, main program. This file contains the entry point of the program. It includes main.h, which provide necessary definitions and declarations. Int underscore config, function for system initialization, example configuring GPIO pin, timers, interrupts. Main calls init underscore config to initialize the system. Enter the infinite loop while one, where the main application logic executes. Next is main.h, header file for main program. Prevent multiple inclusion using hashtag if and df, and define hashtag define derivative. Include t.h, which is likely a standard library or another header required for execution. Typically contains function, prototype, macros, or global variable for main.c. Next is module.h, header file or modules. Defines function, prototype, and constants for module C. Uses hashtag if and def define to avoid multiple inclusion. Other files include the header when they need access to the function modules. Why use this module approach? Code reusability. Function in module.c can be reused in different projects. Better organization, separate initialization logic and function declaration. Third is scalability. Easy to add more functionalities without modifying the main program extensively. This structure is widely used in embedded system programming for microcontroller like PIC16, F877A, ensuring efficient and maintainable code. Now let's see about the applications of this detecting. First is detecting non-metallic weapons. Second, postal screening of envelopes about bacteria. Homeland security application protects potential security harm application, detection of hidden weapons and explosive. And last is chemical biodetection, some security screen, and many more can be the application of this. Advantage of and disadvantage of this project. And advantage in volumetric heating process. Second is quick and convenient method of heating food. And third is user interface and precise control over the cooking temperature. Now let's see about the disadvantage of this. First is cost of equipment is high. Second is unsafe microwave dish will set off a chemical reaction between the food and the container. And third is exposure to high levels of microwave can cause painful burn by heating the body tissue. Conclusion. Microwave processing technology required to learn and understand. Microwave oven will update according to the technology and most likely candidate for future production scale application will take full advantage of the unique characteristics of microwave. During the internship, we have learned how to program the microwave oven where we can control the heating temperatures and timing of the timing for how much time we have to heat the food, and many things we can program using the Pixim lab which we have learned during the internship. Thank you. Now I will be showing the simulation of the project which I have made during the internship. So now we will see that.